Hi class, last week we have learned differentiation, topic 9 differentiation, where the basic differentiation such as differentiate constant, we get 0. For example, differentiate 2, we get 0. Differentiate x power n, we get n x power n minus 1. Or differentiate x power 2, we will get 2x. Differentiate constant multiply function fx, for example 2fx, then we will have 2f prime x. We also learn total cost equal to TR plus TC. Marginal cost is the differentiation of the total cost. And we have learned rate of change, which is f prime x divide fx, or r prime divide r, while the percentage rate of change is the rate of change multiply 100%, or f prime x divide fx multiply 100%. Besides that, we also learn product rule, which is let y equal to uv, where u and v are both differentiable function, then dy dx or y prime equal to uv prime plus vu prime, or u dv ds plus v du ds. Next, we also learn quotient rule, which is y equal to u divide v. If y equal to u divide v and uv are differentiable function, then differentiate y or dy dx, we will get vu prime minus uv prime divide v squared, or v du dx minus u dv dx divide v squared. And this product rule and quotient rule is important, and we will use it or we will apply it in today, this week 10 additional differentiation topics. And next, we also learn consumption function, where marginal propensity to consume and plus marginal propensity to save is equal to 1. And we have learned chain rule 2, where chain rule is dy dx equal to dy du multiply du dx. Power rule, which is let y equal to x squared minus 1 power 4, let's say, then differentiate it, we have to 4 move down, then x squared minus 1 power 4 minus 1, and then differentiate x squared minus 1. So that is power rule. And last but not least, we also learn marginal revenue product, which is the application of the chain rule. Okay, today we will learn additional differentiation topic, which including derivative of the logarithm functions, derivative of exponential functions, elasticity of demand, implicit differentiation, logarithm differentiation, and higher order derivative. We have defined the logarithm function y equal to log a x as for a greater than 0 and a not equal to 1, then y equal to log ax has a domain x is greater than 0. The reason why I say x should be greater than 0 is, let's say we have log negative 3. You can try press log negative 3 in your calculator, then you will get max error. That's why x should be greater than 0. And this is the graph for y equal to ln x. This is how the graph moving from left move up to the right, okay, or from left increase, keep on increasing until infinity. Okay, if y equal to ln x, then differentiate y or dy dx, we will get 1 over x, where x cannot be 0. The reason why x cannot be 0 is 1 divided 0 will get max error. Okay. You can try it by using your calculator. Just press 1 divided 0. you can see max error appear in your calculator. And next, if y equal to ln u, where u is a differentiable function, then dy dx equal to 1 divide u multiply du dx. For example, differentiate fx equal to 5 ln x. Since 5 is a constant, when we differentiate, we take it out, just differentiate ln x, we will get 1 over x. So 5 multiply 1 over x, we will get 5 over x, where x should be greater than 0. And question example 1b, differentiate y equal to ln x divide x squared. Since ln x and x squared are both differentiable functions, so we can use UV, or we can use quotient rule. Let u equal to ln x, v equal to x squared. So dy dx or y prime equal to b du dx minus u dv dx divide b squared. So x squared, we didn't do anything, we put back. Differentiate ln x, we get 1 over x, minus ln x, we didn't do anything. Differentiate x squared, we get 2x. Therefore, we can simplify and we can get 1 minus 2 ln x divide x power 3. Next, find dy dx if y equal to ln 2x plus 5 power 3. So if we want to differentiate this is power rule. We can use apply the power rule function, power rule formula. So y prime equal to 3, move down, differentiate ln 2x plus 5, we get 1 over 2x plus 5. Then differentiate 2x plus 5, we get 2. Therefore, 3 multiply 2, we get 6 over 2x plus 5. I repeat, we can apply the power rule function formula when y equal to ln 2x plus 5 power 3. So 3 move down, differentiate this, 3 constant take out, differentiate ln 2x plus 5, we get 1 divide 2x plus 5, differentiate the terms inside 2x plus 5, we get 2. So 3 multiply 2, we get 6. So 6 divide 2x plus 5. And next, find the f prime x if the function fx equal to ln cube root of 3x plus 5 divide x squared plus 11 power 4. So what we have to do is, first we try to simplify it. So since power 4, 4 can move down, become 4 ln the whole terms. Then ln, since there is ln and divide, so we can put us equal to 4, we didn't do anything. Since there is cube root, so 1 over 3 ln 3x plus 5. And since there is divide, so which means that minus ln denominator, which is ln x squared plus 11. And then we differentiate this. 4, we didn't do anything, we put back 1 over 3, same. Differentiate ln 3x plus 5, we get 1 divide 3x plus 5. And don't forget to differentiate the terms inside, which is 3x plus 5, then we will get 3. Minus, differentiate ln x squared plus 11, we'll get 1 divide x squared plus 11. And don't forget to differentiate x squared plus 11. Differentiate x squared plus 11, we get 2x. Therefore, we will get 4 divide 3x plus 5 minus 8x divide x squared plus 11. If we have a logarithm function with a base other than exponential, then we can use the change of base formula. So let's say log base a x. Then we can change the base by equal to ln x divide ln a. For example, differentiate y equal to log base 2x, then we will have ln x divide ln 2, and differentiate ln x divide ln 2. Since 1 over ln 2 is a constant, so take out 1 over ln 2, so divide ln x, we will get 1 over x. Therefore, we will get 1 divide ln 2x. Okay. If y equal to exponential power x, then differentiate exponential x, we will get the same thing, ex. If y equal to exponential power u, where u is a differentiable function, then dy dx equal to exponential power u multiply du dx. I repeat, differentiate ex will get ex. But somehow, if differentiate eu, e power u, and u is a differentiable function, then we will get exponential power u multiply du dx. Example 5. Differentiate 3 exponential x. Since 3 is a constant, that's why I move out 3. Differentiate ex, we will get ex. Therefore, we will have 3 exponential x. If y equal to x divide exponential power x, so differentiate y or y prime, we will get, since x divide exponential x, and we know that 1 divide exponential x is equal to exponential power negative x. So exponential power negative x is, so we will have y equal to x multiply exponential power negative x. Then we can let uv, or we can use the product rule, where let u equal to x and let v equal to exponential power negative x. Then we can apply the product rule, that is v du dx plus u dv dx. So v exponential power negative x, we just put there, differentiate du dx, which is differentiate u, which is differentiate x, then we will have 1. Then plus plus u is x, we put back, then differentiate exponential power negative x, we will have exponential power negative x, then multiply negative 1, because we are using the e power u. Okay, so that's why we have this one, exponential power negative x multiply negative 1. Then restructure, we can get 1 minus x divide exponential x. Okay. Some students might a bit difficult to digest that, so I'm using Microsoft Word to explain it, and at the same time I will teach you how to add the equation. So this is important for your assignment, because in your assignment you have to create your own questions and you have to solve it by typing all the steps, right? So now let's say we are answering this question. Y equal to, I just put this one first. Okay, then now I want to differentiate this. Then we go to insert, and then equation, okay. Then I just teach you how to type this. Let's say I use back y equal to x divide. Here we go, click script, and then choose the first one, exponential power x. Now to solve this, we can let u equal to x. So du dx will be equal to one. Then let v equal to exponential x. So dv dx equal to, oh sorry, here I missed one thing, equal to x power exponential negative x, which is easy. Then we'll have negative exponential power negative x. Then we will apply the rule dy dx dx equal to, we'll just use that u dv dx plus v du dx, which is equal to x negative exponential power negative x plus exponential power negative x multiply 1. So we will have negative x negative x multiply exponential power negative x plus exponential power negative x. This is, I just expand, I open the bracket from here. Okay, then after that we can group it, become equal to 1 minus x and then multiply exponential power negative x. This is, I just take out, because since exponential power negative x is the common factor, I just take out exponential power negative x. That's why we'll have 1 minus x. Since negative, which means that divide, therefore we'll have 1 minus x divide exponential power x. So this is how we solve it. Okay, then next, find y prime when y equal to exponential power 2 plus exponential power x plus ln 3. Since exponential power 2 is a constant because exponential is 2.718, so differentiate constant will get 0. Differentiate exponential power x will get the same thing, exponential power x. Differentiate ln 3 is a constant, so we'll get 0. Therefore, we'll get 0 plus exponential power x plus 0, which is y prime equal to exponential power x. Okay, if y equal to exponential power ln x squared and ask to find the y prime. Since we know that if y equal to exponential power u, then y prime or dy dx equal to e power u du dx. So y prime equal to, let u equal to ln x squared. So we put back eu multiply du dx. So differentiate ln x squared, since x squared, so we can put down, become 2 ln x. Differentiate 2 ln x, we will get 2 over x. Therefore, 2 over x exponential power ln x squared. So I repeat, this is we just apply the formula if y equal to eu, so we use differentiate y or y prime equal to eu du dx. So let u equal to ln x squared, so differentiate ln x squared, we get 2 over x. That's why eu du dx, where du dx is 2 over x. And next, if y equal to a power x with a greater than 0, then dy dx equal to a power x ln a. If y equal to a power u, then dy dx equal to au du dx ln a. Example 7. Differentiate exponential power 2 plus x power exponential plus 2 power square root x. Since exponential power 2 is a constant, so differentiate constant, we will get 0. Differentiate x power exponential, exponential is 2.7, so it's like x power n, so differentiate x power n is mx power n minus 1, so we just apply the same rule. Exponential move down, and then x power exponential minus 1. I repeat, why we can use this is because exponential is equal to 2.7 is a constant. Somehow, differentiate 2 powers square root x, we have to apply this. If y equal to a power u, so differentiate it, we will get a power u du dx ln a. So differentiate 2 square root x, we will have au du dx ln a. So au, which is, we just put back the same thing, exponential power the whole thing, ln 2 square root x. Then ln a, which is ln 2, then du dx is, we differentiate this one. So we differentiate, we get 1 divide 2 square root x. Therefore, we will get exponential x power exponential minus 1 plus 2 square root x ln 2 divide 2 square root x. And actually, we use this one, we just apply this formula. Dy dx equal to au du dx ln a, where I just let a equal to 2, u equal to square root x, du dx equal to 1 over 2 x power negative 1 over 2. I repeat, for this part, 2 square root x, I'm using this one. If y equal to au, then we have au du dx ln a. So since the question said 2 square root x compared to au, so a is equal to 2, u equal to square root x. Therefore, we have this answer. Okay. Now application questions. When 100 ringgit is invested at 8%, compound continuously, and the amount that accrues after t years, which is called the future value, is xt equal to 100 exponential power 0.08t. At what rate is the money at the end of 1 year? Since we know that the rate of growth or the growth rate is equal to 100 multiplied exponential power 0.08t, And since the question said invest at 8%, so 100 exponential power 0.08t multiply 8%, which is 0.08. Therefore, we will have 8 multiply exponential power 0.08t. And next, at the end of 1 year, which means that when t equal to 1, we substitute inside, we will get 8.666. So why I give the approach sign? Because it should be 26. I mean, you can have like 8.66666 until 7 26. So that's why I put, if I take 2 decimal place, 3 decimal place, and 4 decimal place, and so on, I put approach sign because this means that this is not the accurate or the actual value. I just take the 3 decimal point here, for example. So don't forget the conclusion. Therefore, the future value will change by about 8.67 ringgit during the next year. I repeat, the conclusion is important because this is an application question, so you have to give me the SI unit. Therefore, in conclusion, the future value is 8.67 ringgit. While next, at the end of 10 years, so we just substitute t equal to 10, then we get 17.804. Therefore, we can say that the future value is about 17 ringgit 80 cents. Okay, next, elasticity of demand. We know that from the law of demand that the consumers will respond to the change in the price. If the price increase, the quantity demanded will be decreased. But the degree of the responsiveness of the consumers to price change will vary widely for different products. So the elasticity of demand measures how responsive demand is to change in price. So this is the formula of the point elasticity of demand when nu equal to the change in demand divide the change in the price. So change in the demand, which is P divided Q, and the changes of the price, which is the dPdQ, or differentiate of it. So there are 3 categories of the elasticity. If we modulus the point elasticity of demand, which is and is equal to 1, then we can say that that is a unit elasticity, where the percentage decrease in demand is approximately equal to the corresponding percentage increase in price. While if we modulus the elasticity point and that is greater than 1, then we can say that the demand is elastic. If that's less than 1, we will conclude that the demand is inelastic. I repeat, if the answer is equal to 1, then we can say that has unit elasticity. If greater than 1, demand is elastic. Less than 1, demand is inelastic. Okay, now for example, find the elasticity of the demand function P plus 5Q equal to 100 when the price is 40 ringgit. Since the given function is P plus 5Q equal to 100, and by using the formula, price divide quantity divide the changes of it, dPdQ. So what we have to do is we rearrange the function P plus 5Q equal to 100. So 5Q equal to 100 minus P, Q equal to 100 minus P divide 5, then we'll have 20 minus 1 over P, or 1 over 5P. So differentiate it, dQ dP will have negative 1 divide 5. Therefore, the formula will be price divide quantity multiply negative 1 over 5. If the price is equal to 40, we substitute price equal to 40, 40 plus 5Q equal to 100. So 5Q equal to 100 minus 40, then Q equal to 12. So we will get quantity equal to 12 Then substitute price equal to 40, quantity equal to 12, then multiply with negative 1 over 5, we will get negative 2 over 3. And next, if the price equal to 60, so 60 plus 5q equal to 100, then 5q equal to 100 minus 60, we will get 5q equal to 40. So q equal to 8. Then substitute price equal to 60, quantity equal to 8, then multiply negative 1 over 5, we can get negative 3 over 2. Repeat the same thing. If price equal to 50, substitute inside 50 plus 5q equal to 100, so q equal to 10. Then we will get substitute inside the formula, then we will get negative 1. So to determine the category of elasticity, then we have to take the absolute value, or we have to modulus it. So the absolute value for negative 2 over 3, we will get positive 2 over 3, which is less than 1. Therefore, we can conclude that the demand is inelastic. For B, the absolute value for negative 3 over 2, we will get positive 3 over 2, or equal to 1.5, which is greater than 1. Then we can conclude that the demand is elastic. And the absolute value for negative 1 is equal to 1. Therefore, we can conclude that the demand has unit elasticity. And next, implicit differentiation. Implicit differentiation is a technique for differentiating the functions that are not given in the usual form y equal to fx or x equal to gy. So what we have to do is to differentiate both sides, collect all the dy dx term on one side and the others all in the other side. Then factor it and solve it. Okay, for example, find dy dx if y plus y power 3 minus x equal to 7. So we follow the step here, differentiate both sides. So I differentiate both sides. Differentiate y plus y power 3 minus x equal to differentiate 7. So differentiate y, we get y prime or dy dx. Differentiate y power 3, we'll get 3y squared dy dx. Differentiate x, we'll get 1. Differentiate 7 constant, we'll get 0. So then we take out all the dy dx, we'll have dy dx 1 plus 3y squared, then minus 1 equal to 0, then dy dx equal to 1 dy 1 plus 3y squared. Some students might ask, why I differentiate y power 3, we still have dy dx? Okay. Previously, we have learned if y equal to x, dy dx equal to 1. Then that's all. But somehow for this case, it's different because previously we only have one y, but now we have y and y power 3. That's why this function is not in an usual form. That's why differentiate, we still have dy dx to get there. Okay. And next, let's look at another example. Find dy dx if y, another example. Find the slope of the curve x power 3 equal to y minus x squared power 2. Again, the the y is not only appear one time, because after we square it, the y will have y and y squared. So this is not an usual form. So not usual form, we have to follow this 4 steps again. Differentiate both sides, collect all the dy dx in one side, the rest the other side, factor it and solve it. So differentiate both sides. So differentiate x power 3 and differentiate y minus x squared power 2. Then differentiate x power 3, we will have 3x squared. Differentiate y minus x squared power 2, then we'll have 2y minus x squared. Then differentiate y minus x squared, we'll have dy dx minus 2x. Then rearrange, we will get dy dx equal to 3x squared plus 4xy minus 4x power 3 divided 2 y minus x squared. Then next, the question said at the point 1, 2, which is x coordinate equal to 1, y coordinate equal to 2. So we substitute when x equal to 1, y equal to 2 in this function, we will get 7 over 2 or 7 divided 2. Next, logarithm differentiation. Okay, so for logarithm differentiation, there are 5 procedures to solve it. First, to take the natural log or natural logarithm of both sides, we should give ln y equal to ln fx. Simplify ln fx by using properties of logarithms. Then next step, differentiate both sides with respect to x. Step 4, solve for dy dx. Step 5, express the answer in terms of x only. Example 12. 5y prime if y equal to 2x minus 5 power 3 divide x squared multiply square root of x squared plus 1. So what we have to do is we follow the 5 steps here. First, take the ln for both sides or natural logarithms or natural log for both sides. So ln y and ln the whole things. Then since they are divided, which means that minus, power 3, which means that we can move up, power 2 move down. Since here is multiply, which means that plus, but then since minus plus we get negative. So we'll have ln y equal to 3 ln 2x minus 5 minus 2 ln x minus 1 over 4 ln x squared plus 1. So differentiate ln y, we'll get y prime divide y or y divide dx equal to, differentiate the whole terms here, 3 ln 2x minus 5, we'll get 3 constant, take out, differentiate ln 2x minus 5, we'll get 1 divide 2x minus 5. Then differentiate 2x minus 5, we'll get 2. Minus, differentiate 2 ln x, we'll have 2 over x. Differentiate 1 over 4 ln x squared plus 1. 1 over 4 is a constant, take out. Differentiate ln x squared plus 1, we will have 1 divide x squared plus 1. Then differentiate x squared plus 1, we'll have 2x. So we'll have 6 divide 2x minus 5 minus 2 over x minus x divide 2 x squared plus 1. Then this is, we just take out the common factor and we will left this answer. And some students might ask why we still have this, because don't forget here y prime divide y. So after divide dx will be the whole thing y multiply the things here. So y is equal to 2x minus 5 power 3 and so on. So this is y multiply what we have for the right hand side here. And next, higher order derivative. So if first derivative y prime, second derivative will be y2 prime and so on. Okay, let's move on. If fx equal to 6x power 3 minus 12x squared plus 6x minus 2. So first differentiation, we will have 6 multiplied 3, we get 18, x power 3 minus 1, we get x squared, minus 12 multiplied 2, we'll get 24, x power 2 minus 1, we get x power 1, differentiate 6x, we get 6, differentiate 2 constant, we get 0. Then second derivative, we will have 36x minus 24. Third derivative, we will have 36. Fourth derivative, we will get 0. And next, if there's a constant, differentiate, we'll get 0. Okay, next, if fx equal to 16 divide x plus 4, find the second derivative when x equal to 4. So second derivative, which means that differentiate 2 times. So the first derivative will get 16, x plus 4 power negative 2. And the second derivative we will get 32x plus 4 power negative 3. Then next, since the question said when x equal to 4, find the second derivative. So we substitute x equal to 4 inside here, then we will get 1 over 16. And next, find the second derivative if x squared plus 4y squared equal to 4. So differentiate x squared plus 4y squared equal to 4, we'll get 2x plus 8y dy dx equal to 0. Then dy dx equal to negative x divided 4y, and differentiate dy dx equal to negative x divided 4y, we will get second derivative for y equal to, respect to x, equal to 4y squared plus x squared divided 16y power 3. This is I'm using the quotient rule, which is y equal to u divided v. Then we will have vu prime plus vu prime minus uv prime divided v squared. So we will have this answer. Then simplify it, we will get negative 1 over 4y power 3. And next, if example 15, the XYZ firm's total cost function is 5q squared plus 20q plus 100. If the firm product could sell in a competitive market at a price of 120 ringgit per unit, how many units would you like to sell in order to maximize the total profit, and what is the maximum profit? Since the question gives you total cost, they give you the selling price, which is 120, but then they are asking profit. So we have to use a equation for profit equal to TR minus TC, where TR is equal to price multiply quantity, which is equal to 120q, and then total cost is given, so profit equal to 120q minus the whole thing here. And since the question asks how many units would you like to sell in order to maximize the profit, which means that we have to differentiate this. Okay, so this is equal to negative 5q squared plus 120 plus 20, oh sorry, 120 minus 20 will have 100q, then my negative positive negative. Then differentiate this one, dp dq equal to negative 10q plus 100. Then we will know that to maximize the profit, so we will have negative 10q plus 100 equal to 0, then q equal to 10. Then we substitute q equal to 10 inside the profit function, so we will have profit equal to 400. Okay, and the interpretation will be 10 units should be sold to maximize the total profit, and the maximum profit is 400 ringgit. And no worries for the detailed answer. I will upload the slide in Spectrum where including all the answer. Okay, so that's all for today, where we have learned logarithm differentiation, implicit differentiation, higher order differentiation, and then we also learn elasticity of demand and so on. So that's all for today. Thank you.